DC 2-wire type sensor wiring. So if there is a DC 2-wire type sensor that we want to power up with the power supply, we should make sure never to power up the sensor without a load. So it's a 2-wire sensor, so it will be having 2 wires. These 2 wires we should not directly use to power up to the power supply, as it when the sensor switches on, it is going to pass a heavy current and the sensor will get damaged. So in order to protect the sensor, we should always connect load in series. Okay, so either you can connect the load between your supply and the brown cable, or you can connect the load at your 0 volt and the power supply 0 volt connection. We have here PRWT18-8DC inductive proximity sensor. This is an 2-wire 24 volt DC sensor, but this is an normally closed type sensor. So here DC in the model number indicates that this is normally closed. If you find DO here, it is normally open. So it is with 18 mm size and 8 mm is the sensing range of the sensor. W indicates it is a pigtail type model. That means it is having an 0.5 meter cable, and at the end we are having an M12 connector. Since this is an 2-wire DC sensor, we need a 2-wire DC cable that will be compatible with the sensor. So we can use Autonix CID2-5 sensor cable. So this 2 indicates it is for DC 2-wire and it is 5 meters in length. So we can see we have done the setup here. The sensor is connected to the CID2-5 sensor cable, and at the end we are having brown and blue wires. So brown wire is connected to 24 volts DC, blue wire is connected to a common terminal block, and from this common terminal block we have taken a wire and connected to an LED block. Other end of the LED block is then connected to 0 volt, thus completing the loop. So we can see in this complete closed loop, we are having sensor as well as the LED block. Okay, so both of them are connected in series and the loop voltage is 24 volts. Since this is a normally closed type sensor, as soon as we supply the power, if there is no object in the sensing range of the sensor will normal state will remain closed. Okay, so in the circuit, it will close itself, allowing the current to pass, which can also flow through the LED block and the LED will remain on. Okay, so this condition is when there is no sensing object in front of the sensor. But when the sensor gets triggered, okay, when an object comes in the sensing range and it gets triggered, it will become open, blocking the obstructing the current flow, and thus LED will become off. Let's see this demonstration. So we can see there is no object in front of the sensor right now, and I am turning on the 24 volts power supply. So once the SMPS is started, we can see the LED turned on. The sensor also is showing that it is in triggered state. It's because of its normally closed nature. Okay, we can also verify the model number of the sensor. It is PRWT 18-8DC. Okay, so let's check the sensor with the sensing range. I have kept the sensor at 1 centimeter and I am using this scale as an sensing object. Okay, the sensing range is 8 mm. So let's see, I have brought the object at 10 mm, 9 mm. So when the object reaches 8 mm, the sensor got triggered and it opened the closed loop circuit, turning off the LED lamp. So within the sensing range, the sensor will remain triggered, okay, opening the series circuit. But once I go beyond the sensing range, the sensor gets untriggered, and that is the normal condition for the sensor where it closes the circuit and the lamp remains open.